Good morning and welcome to my YouTube channel again. Perhaps you are doing well. Today I am giving you the lecture for hybridization. So in the previous chapter I have told you that hybridization is the process of mixing of orbitals and formation of same number of same energy orbitals. So here we see the types of hybridization: SP1, SP2 and SP3. So we start from the first type, SP3 hybridization. Here we request you please watch my video till end so that nothing is to be missed and you get full benefit. If you are new at my channel, please subscribe and share to your friends so that they also get benefited. So let us start. SP3 hybridization. So I have told you earlier that hybridization is a process. You can again see what is hybridization. Hybridization, process of mixing of unequal energy orbitals and formation of equal energy level orbitals of same number. This is the process of hybridization. Unequal energy orbital mixed and form equal energy of same number. The new formed orbitals are called hybrid orbitals. So here we see SP3 hybridization. So number first we have to understand why hybridization come into the force. It is seen that in methane there are 4 CH bond. 4 CH bond in methane, in CH4. So if we try to sketch the bond formation, so how will we see carbon? Carbon, you know, 6 1s2 2s2 and 2p2. This will be 1s2 2s2 2p2. This is the electron filled sequence. Here we see 2px is dimensional orbital, so it is divided in px, py, pz. I will tell you the shape of pz. So if we see here, carbon has 2 single electrons. This is called ground state. Carbon always in ground state. So here if we see there is 2 single bonds, so carbon will form 2 single covalent bond. But in methane it is found that it has 4 CH bond of equal length. The CH bond length, all CH bond length is equal. So before bond formation there is some other process that is called excited state. In excited state nearest energy level electron move to higher energy level so that it will show 4 single electron. So these 4 single electron will form the bond. Now 4 single electron, this. 2s single, px, py, pz, that is part of 2p. So now this state, it is assumed that before bond formation, ground state is converted into excited state. Excited state means one electron move from 2s to pz. Now 4 single electron. So carbon now show the 4 valency. And if you see hydrogen is 1s1. This 1s1, only 1s1, 1 electron. So this single electron make bond here. So 4 hydrogen bond. So in CH4, what happened? This hydrogen bond form bond with 2s, px, py, pz. But if it in this situation it form the bond, the energy difference of 2s, px, pz and py are different. You know 2s से एनर्जी ज़्यादा है px की और इससे ज़्यादा py और हायर pz. If in this state, it means ground state, CH4 bond is formed, then every bond of CH will have different energy. So it means all CH4 bonds will have different energy, but practically it has found that all CH bond has equal energy. It means there is in some other process happened before bond formation, so that is called hybridization. So in hybridization, carbon, these 4 molecules, these 4 orbitals undergo hybridization and mix and form new orbital of equal energy. 4 mix, 4 formed, difference energy, then converted to equal energy. So this, then what happened, the new situation? This is 1s and these are the 4 hybrid orbitals. 1s and 3p, it means 4 new, and that are called SP3 hybrid orbital, SP3, and now these all orbitals have the equal energy. This is called hybridized orbitals, and this process is hybridization. If 1s and 3p goes under hybridization for 4 different energy orbitals, as per definition, 4 unequal energy level mixed and form equal energy level, same number, same energy. The 1s and 3p participate in this process. So SP3 is the nomenclature, shows that 1 and 3p mix and formed new orbitals. So we see here, now bond formation take place. Now bond formation take place. Now this hydrogen come and this electron reverse spin. This is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen. So bond is formed. CH4 bond. This bond is between sp3 and H orbital. And here 1s. H means 1s. This is 1s. So CH bond is 1s and sp. Or you can say simple s orbital. Not need to say 1. So here we see carbon is sp3 hybrid. हाइड्रोजन S. So this is all bond जो ये C और H है, this is sp3 and S orbital bond. So now it is clear. Carbon ground state, so two unpaired electrons. It means carbon will show two valency. Every element complete its octet by sharing, receiving or donating the electron. So here carbon has two single electrons, so it should show two valency, but it is found that carbon show four valency, CH4. In all organic compound, carbon show four valency. It means before bond formation there is some other process, so that is called excited state, when nearest energy electron move to the higher energy level and form single electron. But if in this state bond formed, then energy of all CH bond will different. So one more process come into the existence, that is called hybridization. First these unequal energy orbitals mix and form same energy level orbital and called sp3. Then this hydrogen S orbital makes the bond and this become the sp3. So the question is, in CH3 what type of hybridization? sp3 S bond. So I will see you in the orbital form. This I will see you in orbital form. This is the box or energy level form. Here energy of 1s to greater than 2s and so on. So I will give you some pictorial. Carbon, shape of orbital, you note down shape of orbitals. S is spherical. Then p orbital is distorted dumb hells. It means along the y-axis, along the x-axis, similarly along the z-axis. This is z, this is x-axis, this is y, this is z, and this orbital is called, this is pz, px and py. This is distorted dumbbells type. So this is the orientation of p orbitals. This is p orbital, this is s orbital. So what happened? In short, p is shown half, second half. This is plus half, this is minus half. This is plus half, this is minus half. Sorry, this is minus half, this is plus half. Similarly, this is plus, this is minus. This is the nodal point. So it shows very complicated. So in short, we saw it simply in three-dimensional. In three-dimensional, that means e small नीचे दिखाते हैं. Opposite side we see the small, but it is equal inside. So this is the px, py and pz, shape of p orbital. Now how the bond formed? As you know, carbon 6 has 1s2, 2s2, 2p2 and hydrogen 1s1. So in case of methane, what happened? In CH4, this bond, this single electron in positive side, unpaired. This spherical with this half px and py pz form the bond. So if we see px, then sp3 hybrid in carbon, if we see hybridization of this, so there are 4 orbitals. This is p orbit. In CH4, carbon has 4 hybrid orbital. You have seen earlier 4 equal energy. This is sp3. We show the hybrid orbit in this type. In this type we show the hybrid orbital. So sp3 hybrid, you have seen earlier sp3 and this is sp3 having single electron like this. Now hydrogen, in case of hydrogen is 1s1, that is spherical. Such type of 1s1 means only spherical, no hybridization in case of hydrogen. So hydrogen come and form the bond. This is spherical and this paired the electron. This is hydrogen, this is hydrogen, this is hydrogen, and this is the hydrogen. Hydrogen is spherical. So now the octet of carbon and hydrogen completed. So this is the model of methane. This is the model of methane. This carbon has sp3, so the bond is sp3 and s. Spherical is s, hydrogen is s, only s, no hybridization. So bond is sp3 and s. sp3 and all bond length are equal. So the structure of methane is described in this way. Structure of a model of CH4 is shown in this way. So bond is sp, s and sp3. Similarly, if we see for the other alkanes means like ethane, C2H6. Here what happened? 2 carbon goes under same sp3 hybridization. It means 4 orbitals. Then this is sp3 hybrid, sp3, and one this is sp3. Both the carbon are sp3. One carbon with other carbon formed covalent bond. Here one single electron. So all are sp3. Here sp3. The carbon is called sp3 hybrid. It means all the orbitals are sp3. So this carbon is also sp3. So the carbon-carbon bond is sp3 bonds. sp3 and hydrogen of C2H6 circular form come here, form the bond. This is S. So this come 6. Hydrogen is 6. 1, 2, 3, 4, 5, 6. One hybrid of carbon atom for the bond. So this is the covalent bond between sp3 and sp3 hybrid. So here oxygen, now here again oxygen, hydrogen form the bond, and again here hydrogen form the bond. So this is the structure of C2H6. Similarly, all alkanes show the sp3 hybridization. It means you note down here all the alkanes show sp3 hybridization. sp3 hybridization means 1s and 3 p orbitals go under hybridization. Similar, it means this is carbon bond, sp3 and hybrid orbital bonds. This is hybrid between hybrid orbital bond, and CH is sp3 and S, hybrid and unhybrid, between hybrid and unhybrid, hybrid orbitals. So I think now sp3 is clear, as its nomenclature 1s and 3p. 3p means along the y-axis, along the y and along the z goes under hybridization. Here one thing you must note, so write down some points about the sp3 hybridization. The bond angle in case of methane, if you see, the methane is such. This is hydrogen, this is hydrogen, this is hydrogen, this is hydrogen. This type of, this is sp3, this is S. Such type of structure of methane. Here you must know, here one shared pair of electrons. What is shared pair of electrons? One shared, this is called the shared pair of electrons. Shared pair of electron. So due to the repulsion of shared pair of electron, this repulsion, similarly this pair also repel each other, and this pair also repel each other. This should be the position where angle is CH bond angle. This bond angle is 109 degree. So due to repulsion, bond pair repulsion, this structure becomes stable where the repulsion force become equivalent and constant, that is 109. So bond angle C and H ka, this is 109. So you note down, this is the structure, tetrahedral structure, bond angle 109 degree. Number third, S character 25%, P character 75%. One thing you note here, as S character increases, acidic nature increases. So you note down all these points, and I think sp3 you understood better. In the next lecture I will tell you about sp2 hybridization. Till then you exercise one question. Form the orbital structure of propane. propane and find the number of covalent bonds. So you try to understand this problem. I will take in the next lecture. I think you understood the SP3 hybridization. You have no problem. If you have any problem, comments me. We are waiting your comments. I don't know how much % you are satisfied with this lecture. If you have any problem, you comments me. I am waiting. Till then, thank you. See you in the next lecture for SP2 hybridization and SP hybridization in different type other hybridization. Okay, bye bye.